Sweet. All right. Says that I'm live. So, hello, my name is Christian McLaughlin, and we are going to talk about virtualization today with QEMU, KVM, and Libvirt. I'm not new to virtualization. I've been using virtual machines and virtualization for many years, but I haven't, it's all been on Windows. And I was introduced to QEMU, KVM, Libvirt only about 6 months ago. Ever since then, I've been using it every day in my home server. It runs most of the hardware and software in my house, and I use it all the time. I want to show you all of the things that I've learned so that you guys don't have to make the same mistakes, and hopefully you can get any home lab started up in oh, too big. All right, cool. Let me go ahead and fix this real quick. Go under the matrix and let's see if we can. Oh, okay, I see what's going on. All right, cool. They're going to go to display capture. And we're going to edit. Okay, resize it. Okay, yeah. It's going to be this smaller. There we go. Okay, perfect. Yeah, I see what I did wrong now. This matrix thing's getting me. Cool. We'll just go here. And pop there. And then that's it's about as good as it gets. I mean, I might cut off something on the bottom. Yeah, we're good. We'll put it in the middle. Cool. Mission control will let me know if there's any issues. So actually, I think I should be able to reset the yeah, that's fine. I think it should be fine. The PowerPoint isn't really even like the biggest deal. I'm going to put it at the bottom so that way you guys can see the terminal commands on the bottom. That's going to be the bigger thing. So anyways, if the slideshow gets cut off, it's not a big deal. If you want to look at the slideshow, I will upload it so you guys can go through these. I didn't really take that much time anyways making this. So, but anyways, like I was saying, I use QEMU, KVM, Libvirt all the time. So I want to share my experiences with you, any lessons learned that I had, and hopefully you guys will be able to use this in any home lab you want. With Linux, this is a great tool in Linux because you don't really need a whole lot of, you do need a little bit of hardware to run virtualization, but it's not really a whole lot. So we'll go ahead and get this started. So this is about myself. I'm a U.S. Navy veteran. I was in the Navy for 7.5 years. Did avionics work. Got out about 2 years ago as a as an information security analyst. I started working blue team security for about 1.5 years. Switched from blue team to red team. So now I was doing research and analysis work before. Now I'm doing pen testing work. And all of my engineering experience that I have that wasn't my last job is all done on the side. I have a home lab that I work out of. And if anybody's ever interested, I post about it a lot on LinkedIn. I post about it on Facebook and whatnot. But if you guys are interested in seeing it, it's pretty neat. I've been working on it for a while. So, but enough of that. We're going to start talking about cloud computing and virtualization. Now, this isn't a talk about cloud computing, but I hear a lot of people say that they want to get into the cloud and they want to work in cloud computing. I hear it all the time. It's a buzzword that gets thrown around, cloud computing, virtualization. So we are going to talk a little bit about how they are similar, but how they are also very different. So cloud computing and virtualization kind of might seem like they're used hand in hand, but they're really different. Cloud computing is a method, whereas virtualization is a technology. The technology that virtualization is allows for us to do things like cloud computing. Most of your cloud services, if not all of, well, not all of them, but most of them are going to be run off of, a cloud infrastructure or a virtual infrastructure, I should say. So to get into cloud computing, it is extremely useful to understand how virtualization works. The technology for virtualization is freely available. It requires minimal amount of upfront costs to get started in it. And if you're watching this stream right now, or if you're watching this video on any computer, you should be able to get it started. So virtualization, when we talk about virtualization just means it just means like taking and creating an instance that is not necessarily what like a off your host, for example. So when we talk about virtualization in this instance, we're talking about desktop virtualization, which is taking a host operating system or a host application and then creating other guest applications on top of that. You can use and I say applications, I mean like operating systems and stuff. You can use virtual applications, which when we think about virtual applications, we're talking about like O365. That's all, even though that's cloud, a lot of that stuff is virtualized. Virtual servers, virtual networking, virtual storage, all of these are different ways to take a physical device and to combine them or split them up to get other sort of virtual devices. So we're not going to talk about the other stuff, but I want that to be known that virtualization goes way beyond just virtual machines. So why virtualization? It's, as the slide says, it's inexpensive compared to what you would be considered like your traditional IT infrastructure. So before using a dedicated computer for every single person getting a dedicated computer and making that dedicated computer run off of its own OS, and it's a lot of overhead, hardware overhead. So imagine if you wanted to, instead of having 20 computers running, you had one computer running with 20 virtual instances. That would be way more efficient. It would save energy. Oh, that goes on the next one. It's more efficient. It saves energy, but also it's scalable, right? You can purchase the hardware up front and you can build on top of that. And if you buy good enough hardware that allows you to scale and get larger, you can. For example, I purchased a server at my house, and right now I run like 100 gigabytes of RAM, and I have probably like over 20 or 30 terabytes of storage, but I have the capability to expand on that. The motherboard supports up to 1 terabyte of RAM, and the computer can support more storage. Now, I don't even use what I have allocated right now as my maximum, but if I want to take a virtual machine and give it like 8 gigs of RAM and 2 CPUs assigned to it, if I ever decide that my needs in the future need to go higher, I can adjust it virtually, and I can also add more hardware to it. So that's what virtualization has as an advantage. So there are different types of virtualization. The two main ones are full virtualization and paravirtualization. When we talk about virtualization as it is, we're talking about full. Full is where you have a guest operating system or a host operating system on top of your hardware, and that host is running guests, and those guests run independently from the host. They don't really care what operating system the host is running. They do care about a couple of things, such as you might have compatibility issues with CPU architectures, but as long as whatever you're running supports it, you should be fine. It doesn't really care as long as it's supported. The VMs operate independently. They don't talk to each other. They don't really communicate too much with the host operating system as it is. They talk down to the hardware, and they use virtual. There's a virtual hardware mounted on top of that to facilitate communication. Whereas paravirtualization it's a little bit more specific. The operating systems have to be compatible. They talk to each other, and if you make any changes then it can affect how the host operating system changes can affect the guest. One of the advantages of full virtualization is it's portable. If I have an image that I'm running VirtualBox on this machine and I decide I want to take that image and I want to move it over to another computer, I fire up VirtualBox over there. As long as all the versions are the same and everything's good, I should be able to load the image up and then fire it up. You see a lot of times people will have images online that are pre-made for VirtualBox. That's the awesome part about the portability. You don't get that with Paravirtualization. Hypervirtualization is a combination of both of them. You may not see this as much. The most you're going to see is full virtualization. And Paravirtualization actually isn't really even used that much in enterprise environments. It's used for experimenting and testing. And then OS level virtualization, which we aren't going to go over, is talking about oops. There goes my earphone. Oh, I lost audio for a second. Anyways, it's talking about OS level virtualization, which is applications. So Docker, but we're not going to discuss that. But just know that there is a level, another layer of virtualization. And if you don't know what Docker is, you should probably look into it. So nested virtualization, which is it's not like what we were talking before. It is, it's its own thing. Nested just means that you can run a virtual machine inside of another virtual machine. It's not something that you can do infinitely. It only allows for, as far as I know, one layer up. So you can run host, virtual, and then one layer above that. And it's extremely dependent on your hardware. For example, if you have a motherboard that does not support Paravirtualization, you are not going to be able to do it. And even if it does support it, you're probably going to have to enable the option in the BIOS settings before you can actually use it. It's not homogeneous, which means that you don't have to homogeneous. It's not homogeneous. So if I want to run, for example, full virtualization and then a Paravirtualization instance on top of that, or an OS level virtualization, I could do that. In fact, I actually do that in my home server. I have Docker servers running virtually, and those Docker servers host Docker images on top of that. So software versus hardware assisted. Software assisted is going to be hardware emulation through software defined like hardware. And as you can see with the picture, if you can see it, if not, whatever. You have your application talks to your guest OS, which talks to a hypervisor, and they have this thing called binary translation, which is the software talks to on the machine, and then that code gets sent to the hardware. Whereas hardware assisted, it's actually directly on top of the hardware. The virtual machine talks directly to the hardware. And this is where you get into your types of hypervisors. You have type 1 and type 2. So your type 1 hypervisor is often referred to as bare metal. The operating system speaks directly to the hardware, whereas in your type 2 hypervisor, you have this man in the middle, or this middleman, I should say, not man in the middle. That's going to be most of your applications, VirtualBox, VMware, Workstation. Whereas your bare metal hypervisor, if you notice, they're more geared towards businesses. Hyper-V, ESXi, and XenServer. Those are going to be a little bit more difficult. You might see most people run VirtualBox or VMware, Workstation, not really necessarily ESXi or XenServer unless they're doing something serious. But we get into KVM, which is very, very unique. KVM is technically a type 2 hypervisor because it doesn't send directions directly, or because it not because it doesn't send directions directly, but because it sits on top of a host operating system. But it is like a type 1 hypervisor because it does send directions directly to the hardware, is what I meant to say. So on my server, I have Arch Linux running, which is controlling the actual server. That's what gives it its IP address. It's what runs the kernel. Then you have KVM loaded on top of it, right? So KVM is using Arch Linux as its operating system because all KVM is just a software package. That's it. But it doesn't use a middleman to talk to the hardware. It talks directly to it. So you get the benefits of both a type 1 and type 2 hypervisor. Type 1 meaning that it's wicked fast. near native speeds. But type 2, with it being its ease of installation, its portability, not really portability, but its ease of installation and its customization, and you're not really. All right, I'm connected again. I'm working off of the hotel Wi-Fi, so fun. Anyways, but yeah, I should be back online again. Can't wait to do these in person again. Anyways, that's hypervisors. Let's get on talking about that because hypervisors are boring to talk about. Snapshots and images. This is actually an advantage of virtualization. So the ability to take snapshots of a snapshot is pretty much just taking a picture of in time of the instance. So if you're going to do any modification that could damage it, or you want to create a backup, that's what snapshots are perfect for. They don't really take that long to do. I don't want to get too much into snapshots. There's a lot that you can talk about with those. And virtual disk images, all it is a file that sits on your operating system, just a file. Whereas if you were to load your OS onto a hard drive, it would take up an entire partition. This file is your partition. So, and we're going to talk about getting into QEMU, KVM, Libvirt. I hope I am online for this portion. I haven't gotten any communication from HQ, so hopefully everything's good. This is the part where it starts getting fun. We talked about all of the technicalities of virtualization for anybody that really didn't have any familiarity with it or didn't understand what it was. And if you still are confused about some of that stuff, it's good to look it up. But this is where we're going to get in the meat and potatoes. Sweet, we're still doing good. Let's go. So this is what a shot of QEMU, KVM, Libvirt looks like and how it runs. When I talk about things running on top or underneath of stuff, this is like the flow chart of it. You have your hardware, which is the computer. You have the kernel space, which is the operating system and the kernel drivers. And KVM is a driver or is a piece of software, like I said, just like Vim, just like OpenSSH, anything you can do, you can apt install it. It's KVM. It's super simple. Then you have on top of that, you have your QEMU images, or QEMU, which runs which is used to emulate your virtual machines. That receives instructions from libvirtd, which gets instructions from libvirt and virt manager. Libvirtd being the daemon process that runs. But there are other things you can use alternatively to libvirt, but libvirt is the one that usually gets packaged with everything else. Some water. Sweet, cool. Enough of that. We're gonna come back to this later because right now it probably doesn't make too much sense, but we'll come back to this. And hopefully the image makes a little bit more sense. So QEMU stands for Quick Emulator. It is a virtual machine monitor. It just takes care of the actual virtual machines. It gives you near native performance, like I said, just like a Type 1 hypervisor, while executing code on the Ghost OS of the guest OS directly onto the host hardware. But it is technically a Type 2 hypervisor, so because it requires a host operating system to run. It uses QCOW files. I put QCOW2 in there, but there's QCOW, the different iterations are QCOW 1, 2, and 3. I don't think anybody uses QCOW 1 anymore, and because QCOW 2 is the second one. And QCOW 3, I don't use it because QCOW 2 is more popular, I guess, or whatever. For whatever reason, I don't use it. I go with the QCOW 2 format. So what QEMU is going to do is it's going to take an ISO file, which is if you download Linux from the internet, you're downloading an ISO file, and that is your what you would throw onto a USB to boot live and then install on your computer. But instead, in the computer, you don't on your machine, you don't have a CD drive to mount it onto your virtual instance because you're not mounting it. You're not mounting it to a machine. You're mounting it to a virtual machine. So it creates a virtual disk drive from that ISO file, and then it uses that ISO file to burn the disk image into the QCOW2 image file. Here are your QEMU commands, and this is where we're going to start talking about QEMU a little bit more in detail. Let's go ahead and we're gonna go to the install QEMU KVM Libvirt Ubuntu. I should have probably honestly had this pulled up already. Don't know why. We'll go to 2004. Even though 2104 is what I'm running, it's the same thing. It really doesn't matter. This is a checks to see if KVM is okay to run on the system. I know it is. I've checked it already before. Before we get into installing this, I'm actually going to do two demos, kind of, not really two. We'll do them simultaneously, but I want to show you an example of what you can run on these, what you can run on QEMU, what you can run this on. So our first instance is fire up, please. Or no, it's going to go. And if that doesn't work, whatever, I don't care. This is a Raspberry Pi. Let's reconnect real quick. Cool. So this is my Raspberry Pi. It's a Raspberry Pi 4 with 4 gigabytes of RAM. So this is what is not really standard, but this is what a lot of people will have. They have an 8 gigabyte version out there, which I have. It's awesome if you need the extra RAM, but if you don't, you just need this. That's cool. You won't, with a Raspberry Pi being as small as it is, you won't really be running virtual machines on it maybe as much. You'll probably run Docker containers, which even then, Docker doesn't like ARM64 processors that much. But this is just to show you that you can do it, but you're probably not going to be efficiently running virtual machines on a Raspberry Pi. We're just showing that you can do it. So the first thing you want to do is, and I'll go over what interface I'm using in a little bit. I'm just using this to get to the terminal. So we're going to check to make sure that KVM is okay. And what in the heck? No, we're not doing that. Okay, cool. Sudo KVM, okay. And password. And KVM create command not found. Did I skip something? I sure did. Check to see whether it supports virtualization. Paste. Wow. 0. Sir? That virtualization is supported. Okay, never mind. I should read the instructions. Live demos never go well, so we're gonna keep going until it actually does stuff. And yes, I have tested this as much as I can. It doesn't mean that just because it worked before I did this that it's going to work during the live demo. We're not getting that to work. Cool. We already know it's going to be working. We already know it's going to work fine. I don't really care about CPU checker. To be honest, you can run this stuff if you want to. I'm not going to. I don't care about that. We're going to go straight to the install. So installation package. We're installing QEMU, QEMU KVM, the Libvirt daemon, Libvirt clients, bridge utils, and the Virt manager. What this installs is QEMU KVM, which is the KVM part, Libvirt, the daemon, and then the clients portion, which is what's used to control and interact with the operating systems. Bridge utils, which you need that to run virtualized machines, and Virt manager, which is the UI version of Libvirt. What's going on here? So we're going to copy this. Please forgive my mumbling. Cool. Install. Yes, it's that easy, fellas. Do I need it? Oh, man. Did I not read that? You now executing to probe your system. If the key is not present on your server, install it. Do I need it? Check to see if your key is first KVM. Oh, I don't think I need it. I think it just says, talking to HQ here. I don't think I need it. I don't actually, when I install KVM on most machines, when I fire them up, I actually don't install that package. This is what I install right here. So I don't think I do, but thanks for letting me know in case I misread something or overread it. But it's this easy, folks. It literally is that easy. You execute the command, and while it's running, we're going to go over some of the, oh, here it is, cool, it explains to you what each thing is right here. I should have included that in the slideshow. Not. You can look it up on Google. It's not hard. Before proceeding further, we need to confirm whether virtualization daemon is running. We'll do that later once it's installed. So let's go back to the slideshow. We're going to talk about some commands. So we'll execute these commands later just to show you that you can do it. Install in the following. Actually, I might as well install it on my other server too. Not Pi. This is my non-Pi server. Hopefully it works. Maybe. Actually, no, I restarted it, so it should be. If this doesn't work, I really don't care, honestly, because I have a Raspberry Pi running. But I am curious what it is, though. It is 064. Wait, why did I know that's the Raspberry Pi? It is 164. Cool. So I was right. Oh, SSH. No, SSH should be working. SSH not Pi 10 161.1. Yeah, that's it right there. Cool. That should work. And if not, it's probably not even on. I tell you, a lot of demos, man. I'm telling you, stuff never works. This is my you guys are in for a treat. This is my server that I run at home. These are all of my virtual machines. Look how many there are. There's so many. They're all running. Not really. Some of them are running, some of them aren't. Okay, so this machine is running. We're like, you guys are getting some foreshadowing here into what's going to get talked about later, but and I promise you we're going to go over all of this later. Pretend we're just on the computer and I'm just accessing it on the command terminal, not through the web UI. We will talk about the web UI later, I promise you, because it's way easier than accessing things on the computer itself, unless you have access to the machine, which, by the way, I want to let you guys know, I am sitting in Orlando right now. My server is home in Jacksonville, Florida. So I am 200, 300 some miles away from my server. So it's, yeah, what the heck? Weird. So it's, yeah, so this is a perfect use case for my server is running remotely. You know, I don't have physical access to it. Anyways, regardless, this is going to finish installing. I could have pre-installed this if I wanted to, but I wanted to show you guys, give you an idea of how quickly it takes to install it, which it doesn't take that long. I've only been sitting here blabbing for about 5 minutes. And to just give you an idea of the startup of the installation process, which is really what this whole talk is about. We're going to continue from here while it finishes. So what you will do with QEM commands, you're going to, you can look up install, let's see here, QEMU image, is this the right slideshow? Is that the right slide? Terminal commands. Yep, this is the right one, yeah. Install using the following. QEM KVM is going to be the install, it's going to be the install, or QEMU image is the install. So you're going to create with QEMU img create TACF, which is the file type you're going to use, which is QCOW2, and disk image, which is the name of the disk, which is the name of the image you want it to be called, or no, not the name of the image, retarded. No, yeah, that is the name of the image, or disk image, and then yeah, and then the size of the file that you want. Another thing that should be mentioned too is QCOW images are dynamic. Meaning, for example, if I want to allocate 100 gigabytes of storage to a server, a virtual server that I have, when I create the 100 gigabyte image file, it doesn't take off 100 gigabytes on my hard drive. It takes up the necessary amount for the image file, and then as I fill up that file, it then fills up on my server. So I have free space. So what will happen is, if, for example, I have 100 VMs running and I don't run these VMs on my on the partition that is running my operating system, because that would not be smart. Once that fills up, you can go back and troubleshoot and figure out what VM is taking up space, who needs to die, and whatever. We'll go back to that anyways. Let's take a look at status update. This was planned out, by the way. This is not pieced together, even though it may seem like it is. Cool, it's done. Awesome. Next, we're going to get a status on libvirt. So this is using the system control. Paste. It should be running, and if it's not, we will run it. Cool. It's running, active. Cool. Next. We know that's good. I'm not care about enabling it because I'm not going to restart this machine in this talk. So you would enable it. Enable it just means that whenever you shut down the host operating system and you restart it, it'll just automatically start up. lsmod KVM. We're going to check to see if KVM modules are loaded. Yes, we are. Are they? This is where I eat my own words because I probably needed it earlier. Check to see if your system's okay. If the KVM is not present on your server, install it by running. Okay, no, I don't think I need that. I swear I don't need that. You know what the worst part is worst case if I can't get this to get installed, it's already installed on my server. I'll just literally swap over and I can show you guys that. But for the output, you should observe this. It should be running here. We will run KVM command. So we're going to do KVM no machine specified. There's no default, so it's running. The KVM modules are loaded. We're gonna go and we're gonna go ahead and just go for it. And if it doesn't work, it doesn't work. Sudo vir install. Okay, sweet. So this is going to be our virtual machine that we're going to install. Let's go ahead and get it over here, and I can explain it instead of having to read that. Paste. Cool. So we're going to do virt install. Really, was that necessary? Sweet. Virt install. Virt being, like I told you, the is how you interact with the GUI terminal or the terminal. This is a GUI. Name, we're giving ourselves a name, OS variant, Debian 10, how many CPUs we want to allocate, how much RAM we want to allocate, and bit format, graphics, the location. Obviously, it didn't work because this is all preloaded and none of this is on here. And I'm not using an AMD processor anyways. I'm using an ARM processor and network bridge vBurst 0. So this would be normally how you install it. I don't want to go through the installation process because I know it might take a little bit. But also because I want to show you a better way of doing this. We're going to go over these terminal commands quickly just to cover them, but I don't actually use these unless I really, really have to, and then I'm Googling stuff because I don't remember them all the time. Create a Virt Manager machine. Yeah, Virt Manager is the GUI version of how you will manage it. I actually do use, so here's what I'll do. I use Cockpit first. I use Virtual Machine Manager if there's an issue with Cockpit, which there 95 or more % of the time there isn't. If I need to do it on Virt Manager, I'm doing it on Virt Manager either through a remote desktop or actually on the server. And if Virt Manager is really not letting me do what I need to do, I'm going to go into the terminal. And there's been one or two times where I've had an issue where, like, for example, the cockpit package had an error and it was causing my virtual machines to just mess up. I had to go out on GitHub and throw that to them and let them know, but I was able to stop them in the terminal because I couldn't do it on the GUI or the UI. So it is important to know that this tool is there, that you have to use the terminal if you need to. But using it on a normal basis, I don't. I just personally don't. It's not effective for me. And I'm going to show you guys an alternative to doing it. So this is a Virtual Machine Manager. Installing guest OSs on Virt Machine Manager is extremely similar to doing it with VirtualBox. If you're familiar with VirtualBox, Virtual Machine Manager just takes a little bit of clicking around, but it's your graphical user interface for downloading for installing virtual machines. These are all instructions. I'm not going to go over these instructions, to be honest. I will link this somewhere. You can go on this website. It'll tell you how to install KVM QEMU on Ubuntu. If you're doing it on another operating system, like I use Arch, there are obviously other instructions, but you just have to Google it and it'll tell you. There's a lot of documentation for QEMU, KVM, and Libvirt, so plenty of resources. So back to the slideshow. That was a mess. Whatever. We'll be okay. KVM stands for kernel-based virtual machine. KVM is the virtual module of the Linux kernel. So this is what is going to be sitting on the Linux kernel. Like we said, like we showed that picture, there was the hardware, and then inside the Linux box, the box of the operating system for the host, there was KVM, which sat nicely in there and talked to QEMU. That's exactly what this is. There are two modules. There's the KVM-KO module, and then there's the module that you need for your specific processor. The two things that we didn't see when I did that, but to prove it to you, we're going to go ahead and just do that command on the server that I have running right now, just to show you that it can be done. Cool. Copy. Here, terminal. Come on. Paste. Allow. Enter. There they are. Running Intel processors, and there's your other KVM module. That's what you should see when you do it right. I obviously did something wrong on the Raspberry Pi, but I promise you I have installed this before on a Raspberry Pi and got it to somewhat work, and immediately deleted it afterwards because it was pointless to run this on a Raspberry Pi, other than to just the fact that you can do it and to get good at it. But in an environment where you're trying to create something that's productive, you're not going to do that on a Raspberry Pi. Anyways, back to the slideshow. This is a mess. Libvirt. So Libvirt is the interface that is going to be talking to QEMU and KVM. You started the virtual machine with QEMU, but how you interact with the virtual machines is done with Libvirt. So Virt Manager and Libvirt all use Libvirt D, which is the daemon that he uses to talk to QEMU, which talks to KVM. Libvirt being the terminal interface and Virt Manager being the graphical interface. They're open source API daemons. They're awesome. They're very, very powerful. And they use the virsh command in the terminal. I could go over some of them, but if we were to talk about installing and managing virtual machines in the terminal, it would take a long time, and I really want to actually get you guys to the most effective and efficient way of doing it. Not saying that this isn't effective and efficient. If you enjoy interacting with them on the terminal, that's you. Cool. Some of us are psychopaths, some of us aren't. I prefer a better option. Here's your commands right here. There are plenty of them. And I do use these commands, to be honest, whenever I have to, if I have to manually get down to do something, or let's say I don't have, let's say I absolutely cannot connect to, I cannot connect to the web browser for some reason, or no machine's running slow, and the terminal is the only option I have. Guess what? I'll use these. But I don't use these on the often. Here's your overview of KVM, all the things that we learned. But this is the interesting part we're going to start talking about. Virtual machine managers. There are tons of them. You get Kimchi, Convert, Overt, Solus VM, and VMM, which is Virtual Machine Manager. But we're going to talk about the one that I like to use. And when I didn't know about this, that this software existed. I have been using Linux for a long time. I've been using it, well, not really a long time. I've been using it for a couple of years. But it seems like a long time to me. So, but I did not know about Cockpit or what it was. And now Cockpit pretty much gets installed on anything that I have. If I'm using it and it's a server of any type, whether it's a web server, a file server, whatever, I'm installing Cockpit on it. And we're going to talk about what Cockpit is. Cool. We're not going to talk about Virtual Machine Manager. Cockpit project. This is a very well documented and extensive project. When I say it's well documented, we're going to go to the Cockpit project, and I'm going to show you how extensive it is. You can install this. They have installation instructions for everything: Fedora, RHEL, CentOS, Debian, Arch Linux. Even though Arch Linux isn't actually like it's like got like one check mark on here. It's included. It's not tested and supported. Yeah, tumbleweed. Yeah, whatever, same thing. But yeah, so but it has all these instructions on how to install on all these different operating systems. Like I said, I use Arch Linux, but we have our example. We're using Ubuntu, and just so you know, this is my Raspberry Pi right here. To prove it, we're going to go here, and you can see 4 GB Raspberry Pi, 4 GB here, my bad, 4 CPUs, 4 GB Raspberry Pi, and processor it should be. No, that's it right here. Yeah, yeah. This is it. This is my Raspberry Pi. Sweet. Yeah. So we'll go over Cockpit in a minute. As we're going through this. So Cockpit is, let me log out so I can show you the login interface. Cockpit, what you're going to do is you're going to install it with the Ubuntu installation commands. Sudo apt install Cockpit. That easy. It's super simple. Doesn't require any crazy configurations or anything. It's apt install Cockpit. Done. Even on Arch Linux, sudo pacman s cockpit. You don't have to download any R packages. You don't have to do any crazy stuff. It's included in the actual main repository. It's that simple. You get that started up, and when you log in, the first thing you're greeted with is this cool, awesome login page. You type in the IP address of the machine, and you type in the port number, which is 9090 that this uses. And you just log in like you're going to log in with your regular account. So, boom. This is the most scuffed talk ever, but we're having fun. Cool. All right. I could do an entire talk about Cockpit by itself, but we're only worried about the virtual machines. Now, if you noticed, in this tab, there's a virtual machine, or in this one, there's a virtual machines tab, but in this one, there's not. It doesn't come pre-installed with it. You have to install a package, and if I remember correctly, it is Cockpit Machines. Same thing on Arch, same thing on all the other ones, so Cockpit Machines. It's going to open up this little tab here. It doesn't take that long to install, actually. There's also actually a tab for Docker images too, I believe. Let me verify that. If this server is even running, it's not. Cool. All right. Never mind. Blame my last. All right, cool. Machines installed. Now, because there it goes. Boom. Virtual machines. Pop in here. And it connects to your virtualization interface. Yeah, so perfect. Like I said, on this server right here, the virtual machines are aplenty, and they proliferate. They're like bunny rabbits, and that's just how it's going to be. But I'm going to show you how to set up and install a virtual machine on Cockpit. It's way easier than using anything else, than using Virt Manager, than using Virsh with Libvirt in the terminal. It's just way more user friendly because you log into this interface here and you have control over your storage, networking, your storage pools, whatnot. You can do everything from here, and it's on a web interface, so you don't need to be logged into the desktop. So it's not that slow or laggy. So create VM is how you're going to start creating a VM. I don't think I have any images downloaded on my Raspberry Pi. So what we're going to do is we're going to hop on over to, I promise it works on the Raspberry Pi. We're going to hop on over to my main one here, and we're just going to create a one called testing, because test is already taken. So name, system, we're going to go to local installation. Now you can download the OS and install it at the same time. It will take a long time, and we're not trying to do that. I have the images locally. So we're going to download a local image. My images are local on, you have to look for where they're located, mount, ISO, and then I have tons of images. Let's go ahead and install We're just going to do Ubuntu server. No, I want to see something with a graphical interface because I want to show you guys that we'll go with Zorin. Everyone likes Zorin. We'll go with Zorin. Zorin is Debian. So you have to select the operating system that it is. If you don't know what the operating system is, you can Google it. It's not that hard. I promise you, it's not that hard. And you should be able to go to a website like Distro Watch. It should help you out a little bit. And if not, you just got to Google a little further and you'll find it. Most of the stuff that you use is probably either Arch based or it is Debian based, mostly. Most of it's Debian. And if you like Manjaro and other stuff like that, it's going to be Arch. Although Manjaro, I think, has its own in here. So, anyways, whatever, sidetracked. Storage. So we can either create a new storage volume or we can pick one because we can make the image before we use it and then say, I want to use this image. So I think I want to show you how to do it first. So I keep mine under images and you create the storage pool here. I'll show you how to do that in a bit. But you select images, and then you can go down here to all these. These are all the images I have on my machine. Images. These aren't virtual machines. These are just images. Some of them are used and taken up. Some of them aren't. So these are the QCOW2 files, like I was telling you about earlier. But we're not going to. I don't have a pre-populated image, so we're just going to go ahead and create one. Create new. We're going to make this 25 gigs, and we'll give it 8 gigs of RAM. And we're going to not start it immediately because I want to do two things before I start it. You can start it immediately and it will run up just fine, but I want to adjust the amount of CPUs that I have on there because I can't do it in here for some reason. And B, I want to manually set the network because what I want is when this virtual machine pops up on the network, I want it to immediately start using my home network versus a NATed network. So we're going to create it. It's going to be a VM called testing. Down here. If I'm going too fast, please stop me. You guys can't stop me. I'm fast as fuck, boy. All right. We're going to increase the amount of CPUs on there to 4. I'm just showing you just so I can do it. Just so it can be done. I said it can be done, so therefore it shall be done. All right. And then we're going to change our network down here. And you can see in here, you have control over everything. You can change the amount of memory. As you can see, I have lots of memory, and I can choose how much I want of it. We're going to go with 8, though. You can change the vCPUs. Can't really change that. Yeah, we're just going to go with that. And then you have control over your boot order. There's so many options that you can pick how you want to boot the machine. It's just like a regular computer, just like a regular hardware computer, but running virtualized on here. You have stats. You can see the stats of your memory and CPU as they're being used, which, by the way, this is extremely useful because when you come over here to your overview, and you see this is tanking out high, the first thing you want to do is you want to see, hey, where's my max, my memory usage coming from? So that's a perfect tool for that. We have our disk, which is loading, our QCOW image, and we're going to select the network here, and we're going to choose bridge to LAN. The only thing I don't like about this compared to VirtualBox, and this could be because the way that KVM works as a type 1 hypervisor, technically, is when you unplug or make any changes to the network, it doesn't reflect those changes till you restart the machine. A little annoying, but if you get everything set up properly beforehand, it shouldn't be a big deal. You're going to click install, and this is it right here. You get a virtual image right here of the desktop, and you can interact with it right here. We're going to go ahead and install Zorin, and you can see that it is running up just fine. This is a computer running inside of my computer at home. I want to brag again that I'm using Arch Linux as my hypervisor, in case anybody doesn't know I'm an Arch elitist. Cool. Zorn starting up. I don't know why I'm not getting this usage right now. I might have to wait till it's installed, although I don't think that's a thing. So we're going to install Zorn just to show you that we can do it. And because it's only 8 o'clock and I got a little bit more time left, and it doesn't take that long to install Linux at all. So we're going to go next. It's just like installing a regular Linux distro. Stop clicking on it. No, I don't want to participate. Erase the whole disk. This is all virtual disks and stuff, so you don't have to worry about data being lost. Like, it doesn't really affect any of that stuff. Whereas if I was installing this on my main operating system and I had other partitions, I would be a little bit more careful about how fast I'm clicking through things. You'd be surprised how many times I've deleted things because I'm so used to doing it on a virtual machine. We're going to do VM testing. Hold on a second. I don't have COVID. VM password. We're just going to do password. Hack me. Hack me. I dare you. Continue. And it's installing. It's like you're installing a regular operating system on top of hardware. I know that people who are used to virtualization, who are probably not familiar with QEMU KVM, are probably getting more out of this than, or not, are probably getting a different thing out of this. But for those of you who aren't familiar with virtualization, you have to appreciate how awesome and cool this is. I know when we talked in the slideshow about why virtualization, and I talked about all these enterprise reasons, but why should you install a virtual machine? Well, let's say you want to try out a new distro of Linux and you've never tried before, and you don't want to install it on your computer, and you don't feel like putting it on a USB and playing around with the live image. You can install it on here, you can test it out, and if you like it, you can keep using it, and you have the ability to manage your resources and expand or remove them for scalability. You can do all kinds of things with this. Let's say, for example, you want to create, I have, for my virtual environment at home, I've got file servers running that will host my files for my pictures and videos and all the crap that I care about so much. I have backup servers running on those for those files. I have web servers running that host websites. I have other things like Nextcloud. I've got Plex, which is similar to Netflix, but for people who don't want to pay for Netflix. You could do so many things with virtualization. So if you ever get to this point where you install QEMU, KVM, Libvirt, and you pick your first distro, and you're like, what do now? Well, there's so much you can do. It's incredible the amount of flexibility you have. Go on Reddit and look up these projects that people are doing. I'm always coming up with new projects all the time at home. In fact, I'm backed up on the amount of things I want to do because I'm a single person by myself who is struggling to maintain like 20 different projects on a single virtual server. So, by the way, if you are used to building gaming PCs, you want a real challenge, you want something cool, build a desktop server or a Blade server if you really want to be cool. But that's interesting because your specs are going to be way different. You're not looking at something that's graphic heavy that can handle video games. Now you're looking at storage. You need RAM, and you need a lot of RAM, depending on how much you're running. And your CPUs need to be intensive. I don't know if you saw mine, but you can see I got 72 CPUs ready, and I said I had a terabyte of RAM, but it's short of it. Whatever, sue me, I don't care. But yeah, so that is what I got running right now. And it's crazy to be able to do this. While this is loading, I can show you how easy it is to just start up and run a virtual machine. Like you've got, let's say, for example, I have these guys right here, right? I got Gardura. If you never tried Gardura OS, you should try it. I got Manjaro, I got MX, and they're all shut off, but we're going to go ahead and turn them on. Run, 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 and run. They're all going to, well, come on now, start up. Okay, they're all going to start up, and you can see right here, they're all starting up as if they were native native operating system. Let me open my chat quickly. All right. All starting up just like regular operating systems. These actually, I have these VMs installed down here because I am trying out new operating systems. I say trying out, but I've already messed with Manjaro, Garudura, and MX. I installed them because I wanted to use them more. But if I ever want to test out a new OS, I install it on here and I try to get it up and running. I have some compatibility issues with a few, but I'm not going to get into that. Uh, but back to the testing server, yes. Let's see how Zorn's going. Um, this is normal. I don't know why CPU peaks out at 0.2 over what its maximum memory allocation is. I might have to talk to the people at Cockpit on GitHub about this. I don't know why it does that. It's been doing that for a lot of mine for some reason. But I've got the memory available. So yeah, this is taking a little longer than I thought. But it just goes to show you that it's that simple, folks. Let's go talk about storage real quick. Since I told you that you can create storage pools. So a storage pool is pretty much like a collection area that you put your images in. I created a storage pool for my ISO files, and I created one for my image files. So I can see all of my wonderful ISO files. Here you click on ISO, you click on the name, and you scroll down to volumes. And you have all the different volumes here. These are all ISO files I downloaded from the internet, so I don't have to run them off of the URL. And these are all of my images. You can see here how much storage is available, how much is being used. You can go in here and you can see all your different image files. Now, remember when I said that there are some times where you are going to need to use the terminal instead of using the graphical interface? This is one of them. Once you create an image, you can't really edit the name. I could be wrong, but I don't believe there is a way to edit the name once you have it selected. And I do not, I'm just verifying right now. I don't see an option. You can either create or you can delete. That's it. That's all the options you have right now. Obviously, I can't delete that because I think it's running. But if I did BWAP, one or more volumes are used by domains. Okay, yeah, so they're being used right now. But this one's not. There you go. See, it pops up as delete. So, yeah, you have to go into the terminal and you can rename them in the terminal. You can change all kinds of stuff in the terminal. Versh has a plethora of options that you can use. This is just one example of where would I need to use a terminal interface, Libvirt. This is an example. I try to get everything set up right the first time, and if I don't, I just delete the volume and then restart it. But I try to get it all done so that once it's done, I'm not touching it again. So I really minimalize my time in the terminal interface. But yeah, that's how you create storage. And then how you create networks. You have over here, these are your virtual networks, and you have a lot of flexibility on whether you want it to be NATed, open, or none, which means that it doesn't communicate with the internet or any other network at all. It's isolated. None is great for pen testing. I use that all the time when I'm running vulnerable instances. But yeah, you have the option to create networks. So much customization here is available. Most of my networks are bridged because my computers are controlled off of my home router, so they all have private IP addresses that are on my internal LAN. I'm surprised I'm still streaming and it hasn't cut off again. That's cool. Anyways, but yeah, so your virtual networks and your virtual storage pools right here. Everything's accessible through the user interface. You start up, you start down, and you create, delete, edit, and as testing. I'm just trying to think. And installation complete. It's that easy. It's really that easy. Restart now. And you can interact with it here if you want to. What I usually do is I will install No Machine on the desktop, and I will control the desktop remotely with No Machine. I'm not going to go through that installation process just because I can imagine the 9 minutes it will take to navigate to the website, install it, set it up, restart NX server for some reason because it never sometimes wants to start up the first time. We're not going to go there. But you can control it through here. Like I have one up, for example. This is the not the JaxLUG. We're going to go with Europe. Yeah, this is one of my pen testing OSs. It's probably not going to pop up. Probably because it's busy. Are you? No, Parakeet's up. I'm not really creative with my names. Anyways, not really too worried about this. It works. It's not going to work very well because I am on the hotel Wi-Fi in a remote location where my server's all the way in Jacksonville, living off of gigabit connection while I'm over here barely getting a megabit per second. I've tested it. It's that bad. Testing is not coming up for some reason. Failed to fetch IP address of the interface present. Hold on now. We're just gonna shut down. Ooh, we get to learn about errors. Request operation is not valid. Domain is not running. Okay, it says it's not running for some reason. Go back. We was actually working so well so far. We're gonna get rid of this error. It is running. I don't know why it doesn't say it is. We're gonna force shutdown. It is running, literally. Well, then start. All right, how do I start it? Pause. It's not running. Okay, this is an example where you will go into, let's go in here right now. Yeah. Cool, I get to show you how to mess around with the terminal interface. So we're going to look up, it's, if I'm not mistaken, it's first list all? No. All right, I don't even remember. See, I don't have to search it up on here. How do I go back? No. No. All right, ignore all this crap. Oh, there's a back button. First commands. It is it's list all with the the double tag. All right. It's literally the same thing, but with a space and another. Okay. Okay. First list all. And I have nothing running right now. So we're just going to go ahead and no. Let's see. And if this takes too long, I'm not going to really go into too depth. I should have been able to see my VMs and what's running. I don't know why. This could possibly be. You can always do verse tac H if you ever need help with looking up commands. It will give you connect, escape, log file. If this doesn't work, what will end up happening to do is I will do some magic to get it to work, just to show that it starts up. And I will take questions afterwards because I'm not sure if anybody needs questions. Probably gonna grab a light. It's getting dark in here. This is actually pretty interesting. I'm pretty sure that's the domain stuff. I'm gonna start up another virtual machine to see if it works. Okay, and then shut down. It's a parrot. I have to force shut down. Okay, so that works. And now down to testing, and I get an error. Okay. It could be related to Zorin. To be fair, I don't think I've ever installed Zorin as a virtual machine. You run into these issues sometimes where the operating system might not be compatible. I know I've tried to install um, Draugr OS, which is a gaming distro, and it ran into issues with that with installing too. And I know Arch distros with graphical interfaces, the desktops have issues with scaling and whatnot. So you do run into some issues, right? It's not perfect system. It is still a virtual machine at the end of the day, but if you're talking about running a desktop environment in a virtual machine, I mean, that's not really what you want to. I mean, it's not ideal entirely. You're mostly going to be running servers, and where virtual machines really shine is running services. So if you're running servers as in a virtual environment, that's where it's all at, right? Because other than that, you're using desktop graphical emulation. Because my server at home has no graphics cards installed in it, so it's using these emulated emulated like virtual desktops that aren't plugged into any monitors. I don't know why it's not working. Oh, I'm gonna hate myself in a second. Unexpected. Yeah. I gotta put sudo. All right, never mind. I'm just not smart. Let's take a look. That was my fault. So testing is shut off. So we're going to start. We're going to start testing. We're going to start start. I just want to make sure that's what it was called. All right. So we're going to do sudo verse start, and we're going to do testing. Testing. And it started. All right. It's probably just an issue. Like sometimes you have these issues, and this is I'm actually kind of glad this happened. This is a perfect example of, oh, the web UI doesn't work. I have to do it in the terminal. Perfect example. I'm actually super glad that happened. I couldn't replicate that if I tried to. So it started up just fine. We're going to shut down normally just to make sure that this isn't an issue okay, see, perfect. It shut down. The button went away. You run it again. It was just a glitch. Something happened. There was an issue that happened. That's fine. If you have any questions, go ahead and start pulling them into YouTube if you're watching. If you're not watching it live, sucks to be you. Unless you're my friend, then you can hit me up. But yeah, go ahead and start asking questions. I'll answer them as I'm still fiddling around. Since this is kind of like a weird hybrid type of presentation where I am virtual and there's a 60-second lag. So normally, if it was in person, I would just do my presentation and then be done and then answer questions in a polite manner as you raise your hands. We don't have that because of COVID. Let me turn this light on real quick because it's bothering me a little bit. I turned on the wrong light, but whatever. So yeah, anyways, this is the talk. This is it. We tried to install virtual QEMU KVM Libvirt in Ubuntu. I didn't expect this to work smoothly because they never work. If this was at me at home, I would just figure out why it didn't work out on the Raspberry Pi. I actually have a separate server here that I had running to install right here to install virtualization, and this would actually be Paravirtualization because I'm running a virtual machine inside of a virtual machine. So it would really actually be super interesting. But GUI graphical interfaces are like really terrible on here. Yeah, I'm not even gonna play with this. Honestly, I would use if I was at home, I would use No Machine to control this. For some reason, when you stretch the resolution out to 1080p on here, alignment on the arrow. You can see right here. Like if I were to come over here, you can see it's like highlighting off. It's I don't know why. Whatever. I'm not worried about it. I don't use graphical interfaces too much on here. If I don't get any questions and we hit around 8:30-ish, I'm gonna probably go ahead and call it. Since I'm done for the most part. Let me go back to the PowerPoint. I know it was kind of scuffed. We'll be okay. I didn't get too nitty gritty and dirty in the technical aspect of QEMU, KVM, Libvirt because, like I said again, I've only been using this for 6 months. I'm not too familiar with the technical part of it, as in like I couldn't tell you how it does, why it does what it does, specifically as far as when it comes to maintaining or people who actually write code for it. I don't know. I'm not that technical into it, but I hope to get to that point eventually over the years as I start using it more and more frequently. I already use it frequently every day. I use, like I told you, all this stuff. You saw all my servers that I had running, like, you see, like I use this thing all the time. I got all my pen testing stuff going on for work. I've got servers for backup, cloud, file, my web servers. I've got Docker up here running. I've got all kinds of stuff going. These right here I've got going on. Got test servers. I got BWAP for pen testing. That's my Voyagers for my torrents. So I mean, you've got quite a bit. Where did everything go? There we go. You got quite a bit of stuff running. And this is not built in a day or two. This is built over time. And most of the servers that you see on here, like my Docker server, has been rebuilt like 3 or 4 times. I've killed it, restarted it, done it differently. It's just, it's the nature of it. Virtual machines are meant to be asker it, delete it, destroy it, and retake it up again. If you host like your files separately and you share everything with Samba, but anyways, yeah, so I do use it frequently enough to be that familiar with it. Skip through this stuff. I really would like to have gone over Virt Manager, Machine Manager again, but I'm going to be really honest. It is just like VirtualBox if you're used to using VirtualBox. If you're not, don't even download VirtualBox. Just download Virt. Just download what I told you to, and you'll be fine. Unless using Windows, then. Oh, that's another cool thing too. So QEMU, KVM, and Libvirt being individual packages, right? Libvirt being the interface that you use, right? QEMU and KVM can be used with other virtual machine managers, like you can use it with VirtualBox. So they're like a stack of software that's used and they interact with each other. There's no one singular software that's used. They're all used together. So that's really interesting if you can, if you didn't know that. Things that we didn't cover today: emulation for video games. I don't even get into that. I just put that for no reason. Containerization with Docker. I want to express that if you haven't used virtualization that much, use this, download it, and then once you got a hang of it, download Docker, because Docker is even better in some ways. You're talking about applications that are megabytes versus gigabytes. If I want to download a web server, what would I do if I wanted to download the web server on Ubuntu? I would, apt-get install my LAMP stack first. So I gotta set up a SQL database. I gotta download Apache or whatever, and I have to download my PHP, and then I have to download WordPress and set it all up. Or on Docker, you can just download the image, and it's done. Now, I don't want to get too much into Docker because this is not a Docker conversation, but I'm trying to tell you that play with virtualization and then play with Docker. It's amazing. A lot of these companies are moving over to, if they haven't already, full virtualization or mostly virtualization, and they're using Docker for a lot of this stuff. So this technology is getting used in an enterprise environment. If you want a job and you want to be skilled at something, and you want to have something on your resume, I know how to use virtualization in Linux. First of all, I know how to use Linux. Then I know how to use virtualization with QEMU, KVM, Libvirt, and I know how to use containerization with Docker. And then if you want to go another step above Docker, learn cluster computing with Kubernetes. Then you're really talking about another skill you can add to your resume. This information is freely available. There's plenty of YouTube videos. I'm sure if it comes into the future, there might be a JaxLUG talk about it. But everything's available online for free, not just information, but like to download this stuff. Like this software is free on Linux. So like download it for real. Other things we didn't talk about too was WSL and AWS, because those are all really popular platforms that are available. WSL, which is Windows Subsystem for Linux, came out not long ago. I think it was only a couple of years ago, maybe 2 or 3. It lets you run Linux on Windows. It's not perfect. It is not technically a Linux virtual machine per se, but it is a virtualized instance of Linux running on Windows. So you can't do everything that you can normally do on like you can't manipulate the files and stuff on your computer with it, because everything still uses Windows your file structure, not Linux. So you're not over here using different disks, whereas on Windows you're using partitions. But if there is a program or a package that you need to run on Linux that you can't run on Windows, WSL is perfect for that. If I needed to run, for example, uh, uh, Nmap is available on Windows, but let's say, for example, I didn't want to deal with that and I wanted to download it on Linux. You would start Windows Subsystem for Linux and you would just run Nmap in there, and it runs as if it was running on the computer. It's perfect. AWS, if you don't know what AWS is Amazon's web services that most companies use. They have actual certifications from Amazon to teach you how to use their virtual environment in their cloud. It's actually like putting those on your resume. Putting AWS certifications and stuff on your resume is actually like skill worthy. So if you want to take the time to learn that, by all means, do it. And SolarWinds, yeah, we won't talk about that because obvious reasons. But yeah, no, here's some references. I plugged these in here because I literally went to these websites and copy pasted information from them and then put it in my own words. But I use them to help build the presentation. But these aren't like the best resources. There are better ones out there that can teach you, that can show you more. This is just what I put for presentation. So, end of the slideshow. I haven't gotten any questions from anybody. Yeah, screw it, whatever. Okay. I know this is a scuffed talk. I would not be surprised if I'm not invited to talk again. But I like to try to have fun with my talks, and I like to try to make it a relaxing environment. So, if you've ever talked before, you know that nothing ever goes smoothly as it's intended to. And I felt that as much, I prepared for this. I volunteered for this like 4 days ago, and I prepared for it 3 days ago. And normally, sometimes how it goes. But anyways, I don't want to talk about that. So, but yeah, that's virtualization with QEMU, KVM, Libvirt. This was only meant to give you a small peek at it, to get you interested enough to Google it and download it on your own and play with it, right? I showed you a technology that exists. I demoed it for you. I did a crappy job demoing it, but I demoed it for you nonetheless. And now, hopefully, I've compelled you enough to go out and try it on your own. Because the best way to learn isn't to watch videos and read books and stuff, is to get your hands dirty and do it yourself and find an application, find a use for it, right? And the only way you're going to actually get good at something is if you get your hands on it. So I encourage everyone who's watched this to please download it and get heads on and your hands dirty. If you need to ask me any questions, I'm in the Discord for JaxLUG. If you want to join, it's you can freely join it. We're a pretty chill group. I am on LinkedIn. I didn't put my LinkedIn on here, but if you look up, yeah, well, we'll go here. I'll show you guys. I'm wearing a pink suit, so or it's salmon suit. Here you go. Cool. See, this is me right here. Just look up my name, and this is me with Boba Fett and me. You can ask me any questions. I will take so much time out of my day to help people with anything they need because so many people have come and they've helped me. And that's how I like to feel like to give back. So if you take an hour, 2 or 3 out of my day, or you want to learn more, I am more than happy to teach you. Please reach out, ask questions. Online forums can be harsh. Let's be real. Reddit, Facebook, people can be really, really nasty. But the JaxLUG group and myself especially, if you have any questions, we're gonna be there to help you to get better and to learn more. So yeah, that's the presentation. So yeah, I hope you guys learned a little bit and were inspired enough to go and download it. So see you guys on the internet.